So, got a massless rod, mass is M1, M2, M3 at positions X1, X2, X3. Left-hand side at position X equals 0, right-hand side at position X equals L. Want to know what the torque of this system is if we pivot it about the left-hand end. Okay? So, first of all, torque is your moment arm times your force, moment arm times force, moment arm times force, right? It's the sum of all your moment arms times your forces. Well, moment arm is X1 here, X2 here, X3 here. So you're going to have X1 times M1G, X2 times M2G, X3 times M3G. Okay? And that's this. That's a magnitude of the torque. The vector form of the torque is by cross products. Okay? You have the R vector and the force vector, right? And if I'm going to make that a force vector, just like I was telling Elam earlier, I better put arrows over it so that nobody gets confused, especially me. Okay? So now we have vectors, and the torque is R cross force. Okay? The R vector originating at the axis, which is going to be the tip of the fulcrum. Okay? And what's the magnitude of R1? Well, R1 is perpendicular to G, isn't it? In every case, the R vector is horizontal, the G vector is vertical, and everything else is constant, right? So the magnitude of R1 is X1, right? Magnitude of R2 is X2, magnitude of R3 is X3. Okay? So, probably need more room down here, so I'll just kind of obliterate this part of the picture. This equals, since X is in this direction, Y is in this direction, what's the direction of Z? It's a right-hand coordinate system. Cross the I vector with the J vector and you get the K vector, right? So it's out of the board. Magnitude of R1. Okay, I could write these out. I'll go ahead and write these out in terms of I, J, and K vectors.
It should be into the board.
Right hand.
Yeah, but it's rotating clockwise.
Yeah.
Huh?
The rotation is actually this way.
I don't care, I'm talking about the Z-axis.
Oh yeah, okay.
Okay?
The torque will be in.
I'm orienting it to the three-dimensional coordinate system. Yes, these R cross F is going to be into the board, so it's going to be a negative multiple of K, isn't it? Well, we haven't gotten there yet, but since you anticipated it, yeah, you're right. It doesn't change the fact that the Z-axis is out of the board. So if it's into the board, it's in the negative Z direction, right? In other words, the direction of the negative K vector. Okay, so anyhow, R1 is X1I, right? Because I this way, J this way, so all these are negative multiples of K, right? Okay, so, negative multiples of J, sorry. Okay, so we have this cross with M1G, negative M1G, J. Okay? Because G is in the negative J direction, right? Negative Y direction, multiple negative J. So it's going to be M1G times negative J. So that's just negative M1G times J. Is that clear? Okay? And then we have R2, which is X2I crossed with negative M2GJ plus x3I crossed with negative M3G J. Right? Now we've got constants. X1 and M1 are constants, so we have negative M1 X1 times I cross J. And I cross J is K, as we just mentioned, so we have negative M1 X1 times K here, right?
And G.
Did I lose G?
Yeah.
There's G. Okay? So that equals negative M1 X1 G, and it's times K. Well, similarly, in each case, you get then, plus a negative M2 X2G times I cross J, and a negative M3 X3G, and G is not a vector right now, times I cross J. So we're going to have negative M2 X2 GK minus M3 X3 GK. Of course, we can factor all that out. So we have negative M1 X1 plus M2 X2 plus M3 X3 times G times K. And there's our torque, a vector torque. Okay? Okay, well, I had these pictures. Let's do this about the halfway point. I don't want to do all three. I'll leave a third one for you to do. Okay? So about the halfway point. So, write down the vectors.